Going to start recording. For the procedure, as long as no, for procedure you can be brief. Just the questions like procedure, we have them for experiment 1 basically. It's just trying to get you used to like step by step. If you're writing, how would you write it in a way that you can perform the experiment? But starting experiment 2, the procedure stays in the lab manual. It's more of questions about that experiment in form of the just like pre-lab questions you had for experiment 2. Then it will continue. So you don't have to write more procedures. Is this for regarding the data sheet for experiment 1 or experiment 2? Hannah, your questions. Experiment 1, no, you don't have to start with the material, really. You just have to say what steps, what are the steps, like how would you measure? You can start from like having all the equipment, like every equipment is available to you, and you are trying to get the, like measuring the mass. What would you, is basically when you are measuring the mass, like which method are you going to use? By difference or by direct measurement, or which method are you going to use, basically, to differentiate between them? Okay, I hope I answered that question. Any other questions? You're welcome. Any other questions? Okay. For the for today's experiment, it's the difference between physical and chemical changes. Okay. What is a chemical change? What's the difference between chemical and physical change? Start with okay. Chemical change is not reversible. That's good. Not reversible. Chemical change rearranges the composition of the substances, basically new compound forms. In physical change, what happens in physical change? Okay, physical change is just change in state. The composition of the compound does not change. That's physical change. Chemical change usually creates some sort of new substance. Yes, it always creates new substances. Okay. Now, what is chemical property versus, what's the definition for chemical property versus physical properties? When you say chemical property, what do you mean versus when you say physical properties? Physical, example of physical is color. Chemical property can only be observed through chemical change. Okay, very good. Properties caused by reactions are chemical. Chemical property is ability to For example, ability to rust. That is a chemical property. Okay. Physical property can simply be observed like color or odor. Very good. So in a physical property, basically you can is a measurement or observation by either using your senses. You could see them, you could touch or feel it, and also could be measured without or determined without changing composition of the compound, as some of you said it already. So physical property can be observed or recorded or determined without changing composition of the compound. So when you look at an element, a substance, you're looking for color, the state of the compound. Is it solid, liquid, or gas? That's also physical property. Is it shiny? Is it malleable? Is it the type of physical property? What's the temperature? That's physical property. If you want to determine chemical property, you have to change the composition of the compound, or you can be determined by changing composition of the compound. For physical changes, you just see the change in appearance. Like when you cut piece of paper in half, or anything in that nature, like you grind like crystals to change it to powder, because composition of the compound doesn't change, is physical change. But when the change involves change in composition of the compound, that would be chemical change. Now, physical change is easy because you could watch, you can observe, and then look at the state. If the state changed, if the appearance has changed without changing composition, it's easier to determine by simple devices in the lab, like a thermometer to look at the change in temperature, or by just observing with your senses. What about chemical change? How would you make sure, or how would you predict if there was a chemical change? What are evidences for chemical change? So basically, chemical change is a chemical reaction, right? Chemical reaction must happen for you to say there is a chemical change. What are the evidences for chemical change? Because you won't be able to see the chemical change. Changing, now sublimation is going to be physical or chemical? Is sublimation physical or chemical? It's physical because it's just change in state. So sublimation is physical change. Change in color, bubbling, basically formation of gas, okay? Formation of a gas. Burning, that is example for chemical change. However, if you are looking for evidence for the chemical change, so when burning takes place, let's say a paper burns, what do you see that you could conclude there is a chemical change? What evidences would make you believe that there was a chemical change when you look at like burning piece of paper or burning wood or burning something? That's what I am asking, basically the evidences for formation of evidences for chemical change. When you are combining two liquids, a solid compound forms. That's what Davis you mean, right? When you are combining two liquids, two clear liquid, a solid compound or powder forms. That means you have a chemical change. And Hannah, you said when okay, formation of ashes as a result of burning, that indicates that there was a chemical change. So when you look at the ashes, that's like a specific case, but when you want to say in general, see, that could be like a color change. You have a white piece of paper, and then you get like gray color ashes or black color residue, and the composition is basically, the appearance also is changing. So you have like a flat piece of paper, and then you get like powder ashes with at the same time is color change. It's not that you grinded the piece of paper to get to the powder as a result of the burning. Gas or smoke is created. So in a chemical reaction, we said composition of the compound is changing. Since composition of the compound is changing, a new compound must have form. So in a chemical change, a new compound is forming. Now, the evidence is, as I'm just referring to some of the responses that you had, and they were correct. So you have to look for evidence, evidence of formation of a new compound. Like the example that you said, you have two clear liquid, you mix two clear liquid like silver nitrate and HCl, and then you would see white powder is forming. Well, none of the two reactants. So we look at the reactants before mixing. Silver nitrate is a clear solution. It looks like water. It's not water, but looks like water. And HCl also, it looks like water, is clear liquid, transparent liquid. When you mix the two, when you are mixing, that's like you're trying to see if there is a chemical reaction, and then what is formed, that is product. So when you see white powder is forming, the white powder, if you can see the white powder, that means that compound was not soluble in water. We call that a formation of a solid or formation of a precipitate. So when the precipitate forms, that means your compound, then it's not soluble in water. And the point is that two compounds that you mixed together before the reaction, they were both soluble in water. Now, after mixing, if there is a compound that is not soluble in water, must be different compound from the two that you mixed. And if it's different compound from the two that you mixed, it must be new compound. So when you came to a conclusion that it must be a new compound, that means you have a chemical reaction. A new compound has formed, that's definition for chemical reaction. A new compound has formed, that means composition of the compound, the original compound or the reactant has changed. So it's the evidence for chemical reaction. So formation of precipitate, that one evidence for reaction. Change in color. You also mentioned change in color. Change in color, that's indication for chemical reaction. It's not going from dark blue to light blue. If it's going from dark blue to light blue, you could just have like a blue color solution. You add water, you dilute, it can go to light blue color. But if you start like a blue color solution, and then after mixing with, let's say, blue color solution like copper sulfate. Copper sulfate is a blue color solution, and you mix that with magnesium. Magnesium is gray color. Now, when you mix magnesium with copper sulfate and you leave it alone, after a few minutes, you would see that magnesium, the gray color, has disappeared, and new powder has formed. The magnesium is like a ribbon, and if that disappears in the mixture, a new powder is formed, and the new powder or solid compound that is formed has a red color. That is new for changing color. Also, the copper sulfate is a blue color. When the red color of copper forms, basically copper sulfate is changing to magnesium sulfate, and copper coming out of the solution. So magnesium sulfate is colorless. So when you see the blue color disappeared, a red color, the powder has appeared, both you have two evidence there. One, the blue color has disappeared. A second one, the gray color, the ribbon of magnesium has disappeared. Now we have red color copper forming. So a new compound must have formed, right? Because you are not, even alchemists. If you are an alchemist, you have to change the composition of the compound in order to see that color change. So magnesium is, you're not turning magnesium to copper. What you are doing, actually, you are making, as a result of the chemical reaction, you are making a new compound. Magnesium goes into the solution, copper comes out of the solution. You will learn soon in lecture and also in experiment 7 for the lab that type of reaction is called single displacement reaction. Magnesium goes in, copper comes out of the solution. So that is there are two evidences there. One, formation of a solid or precipitate. Second is color change. Evidence 3 would be change in pH. So if you have a solution with pH less than 7, so you have acidic solution, and you add base to it, base has a pH higher than 7, between 7 to 14. When you mix the two, acid-base reaction or neutralization reaction takes place. So if you measure the pH before mixing of one of the solution and is less than 7, after you mix with the second compound, you measure the pH again. Now the pH is 7. That means the acid has been neutralized. So change in pH indicates that there was a chemical reaction. So your original compound had a pH less than 7. That must have been acidic compound. Your final product has a pH of 7. That means you have a neutral compound. So if acidic compound changes to neutral compound, there must be a chemical reaction because a new compound has formed. So change in pH, change in color, change in temperature. A change in temperature is different from, so when you say change in temperature, you have to keep in mind that you're not bringing external heat. So if you have a mixture and you are going to start heating up using Bunsen burner or hot plate or stove or the oven, you are applying external heat. But if you mix a solid white powder with water at room temperature, and after you mix it, you touch the test tube or you touch the container, and the solution gets hot, the temperature goes up. That's what I'm talking about, change in temperature. When the temperature goes up, that means there must be a chemical reaction, and this type of chemical, this is the last part of the experiment. Actually, you actually go when you mix the ammonium nitrate with water and sodium carbonate with water. One of them is exothermic, the other one is endothermic, and when you watch the video, you would write down your evidences. So if you mix the powder with water and the temperature of the solution goes up, first of all, that powder dissolves in water, and then the temperature goes up. That is a exothermic reaction. That means the heat has been released. If heat has been released, that means a new compound has formed that is more stable or has less internal energy compared to the original compound. The excess amount of energy has been released to environment. So the reason heat is released, because there is something going on. The composition of the compound is changing. So when you burn gasoline, the composition of the compound is changing. It changes to carbon dioxide and water. So you have your hydrocarbon or gasoline changing to carbon dioxide and water. Carbon dioxide and water, they are more stable than the gasoline, or they have less internal energy. So the old bonds are breaking, new bonds are forming, that means chemical and reaction, and heat has been released. So if heat is released as a result of mixing two compounds or making compound go through chemical reaction, that's evidence for chemical reaction. There must be a new compound. So formation of gas, that's another evidence for reaction. Formation of gas is like you take piece of zinc and you add to hydrochloric acid. Zinc in hydrochloric acid, metals dissolve in acid, hydrogen gas is released. So when one of you mentioned about bubbles, that bubbles is not air basically, it's the gas that is produced as a result of, is not like boiling, is not evaporation, because evaporation also can cause bubbles, right? But it's you see the boiling process, so bubbles are forming. But if you have you're mixing solid zinc with liquid HCl without applying any heat, then you see bubbles are forming, then you're going to see that take that as evidence for reaction. A gas is forming, there must be a new compound, because none of the original compounds that you mix were gases. So zinc was solid, HCl was liquid, you mix the two together, now you see gas is forming. Since gas is forming, it must be a new compound. So as soon as you say it must be a new compound, that is clear that you're saying there is a chemical reaction. So that becomes evidence for chemical reaction. Can you tell me how many evidences I already mentioned? You don't have to say all, you could just type one of them at least. Okay, color, changing color, changing pH, changing temperature. So Davis, you mentioned 3 of them: changing color, changing pH, and changing temperature. Okay, and formation of gas, formation of gas, formation of, there's another formation. One more. In total, you have precipitate, yes. So formation of gas, formation of solid, then changing color, changing pH, and changing temperature. Those are evidences for a chemical reaction. So if you witness any of those 5, there must be a chemical reaction. So when you are looking at when you are trying to record physical property, you just have to look at it is basically by observation or determining without changing composition of the compound, but chemical properties, you have to change the composition of the compound. So basically, chemical property is the ability to go through a chemical reaction. That is chemical property. For example, sodium with chlorine. Sodium is reactive gray color metal, highly explosive, because if you mix with water, it causes like huge explosion. Chlorine is toxic gas, yellow color, very toxic gas. So when you smell like bleach, that's the smell of chlorine, or the smell or odor of the bleach is coming from the presence of chlorine in there. When you mix the two, if you mix sodium chloride, if you mix sodium with chlorine gas as a result of chemical reaction, you will see white powder is forming, and that white powder is the edible table salt. So the formation of a precipitate or the white powder, along with like the changing color and formation of the heat or change in temperature and all that, you would see the heat is released because you would see like flame. That reaction is highly, because your chemicals, they're highly reactive and the product is so stable, the extra amount of heat needs to be released to environment, and you would see that in form of a flame. Actually, you can search up and you know, Google formation of NaCl. You would see that it's going to cause lots of fire, and then at the end you would see like a white powder is forming. So for chlorine to be able to react with sodium, that's chemical property. So the ability to go through a chemical reaction, that's chemical property. Sodium is able to react with chlorine, that's chemical property. So when you look at the chemical properties, physical properties are the ones that based on the color, based on the appearance of the compound, the state or appearance of the substances. So experiment 2, it's different from experiment 1. In experiment 2, you don't have to write the procedure, is a shorter experiment. It's at the same time, it's very important because it's trying to help you understand the difference between physical changes and chemical changes, and also what are physical properties, what are chemical properties. So change in state is considered physical property because the composition of the compound does not change. The only thing that is changing by increasing the temperature, when you increase temperature, what you are actually doing? You are heating up the sample. You give external heat, and that heat is going to be stored within the molecules of the solid in form of kinetic energy. And then when you give kinetic energy to molecules, they start moving around. It's like giving a chocolate bar to like a toddler. Then they start like moving around. They get like active. Okay. Now, if you increase the temperature from liquid to gas, what is happening? You're basically storing more energy in each molecule. You're giving like 10 chocolate bar in like 2 hours to a toddler. Then you make that kid like hyperactive, and you can't just make them, you know, stop. They're going to just run until they exhaust that excess of energy. And the liquid molecule, same thing. When you give enough energy, that energy is going to be stored within the molecule. Then they start moving around. And as long as they are moving around, constant motion, they're behaving like gas molecules. But if you look at the diagram, the figures that I have 2-1, the composition of the compound does not change. It's just that spacing between the molecule is changing. So change in state is a physical change. How can you reverse the process? What would you do to go from gas to liquid to solid? That's like reversing the process. What would you do? You would lower the temperature. Very good. If you lower the temperature, then you are taking away the heat. So when you take away the heat, you get your molecules is going to have less energy, and when they have less energy, they try to just sit down. And when they're sitting down, they're getting close to they're all coming down as a liquid. And then if you further cooling, when you remove any energy of motion, when you make the molecules to stay solid, that is formation of solid in a fixed position. Then you have a solid compound. Classification of the compound, pure substances and mixtures. Mixtures what's the difference between heterogeneous and homogeneous mixture? Is there anyone who has not answered any questions? Kaden, I think you did. Soroti, did you answer any question? And Monisha, Jada, Sierra. I see. I don't want like 5 or 6 people to answer questions. I want everyone to try. I haven't seen, I think, answer from some of you still. Leah, Ria, Sonia. And if you have answered, forgive me, is that probably did not just correct? Okay, very good. Homogeneous, the other name for homogeneous mixture is solution. Please, if you are mixing like salt and water, you mix it well, then you take a sample from any area of that solution should have same density. So composition of the compound is the mixture. Yes, Carmen.
Hi, I just have a small question. So last night on the pre-lab, I saw that air was homo, but I thought it would usually be hetero due to how it gets thinner when you go more higher into the atmosphere. So I was just curious how it's still homo.
Okay, air is the homogeneous.
Mm-hmm.
That's the question. I'm trying to understand the question first. Air is a homogeneous.
Yes, but as you get higher into the atmosphere, you get more lightheaded as you go up. So I was just thinking, wouldn't that cause some change in the material in the air, like how you would have less oxygen but more of another gas? Or was that just like lack of air still causing it to be homo?
When we are talking about substances, we are talking about the sample of the whole sample, right? So if you take 1 cubic meter of air, so it's that if you put in a container, then you look at that is homogeneous, right? So if you go to the to higher elevation and you take 1 cubic meter of the air, is still homogeneous. And homogeneous is like when you are looking that the sample that you are studying is homogeneous. The higher the elevation, there's lower pressure. Okay, lower pressure, and that means less number of molecules. So if you look at the sample, again, but in general, if you're trying to say that the layers based on the density of the molecules that they exist in the air, maybe the heavier one, they are lower and closer to the surface of the earth, and then the lighter one away. That is good argument, and it is true. But when you are talking about in chemistry, we are talking about like sample of the air. So you take a container of the air and you look at it. But if you study like in general, you don't call that air, you would call that atmosphere.
Thank you.
Right? You're welcome. So homogeneous mixture, the other name for it is solution, and it's the same throughout. When you have heterogeneous is the component of the mixture. So both of them are mixture. It's not uniform, and the component of the mixture is going to maintain their own properties. So when you have mixture, example of heterogeneous, give me an example of heterogeneous, and then definition would be that they maintain their property. You could see them separately. Example for heterogeneous? Sand and water mix. So you could see the sand, you could see the water, a salad dressing, oil and vinegar, a garden salad. They are all heterogeneous because you could see the different component in the salad. A sandwich, it's the, you would see the different pieces in there. So it's the heterogeneous. Okay, very good. About the element and the compound, those are both pure substances. So pure substances, it could be element or it could be compound. Very good. Okay, any questions? Just note the definitions when it's going from one form, but is a change in state again, from solid to liquid to gas. These definitions, it helps you for lecture, it helps you for the lab, and know that change in state is just based on the amount of the heat that you apply. For exothermic, endothermic, if the heat is on the product side, that means heat is created or temperature has increased, that's exothermic. Endothermic is that the evidence for endothermic reaction is that temperature is going to be decreased because the reaction needed heat to happen and it took away heat from the environment, so the environment got cold, lower temperature. And that's the conductivity. It's a physical property. And metals in general, they're conductor of the electricity. Non-metals, they're non-conductor. Air is not a good conductor. Sometimes when you watch the video, if they gave me like a piece of copper, that's conductor of the heat. If it's just one copper wire, it's conductor of the heat. But if you have pieces of copper in one container that is separated by air or space between them, even though the copper is conductor of the electricity, but if there is space between them, that space prevents the conduction of the or moving of the electron, and the result of the experiment may not be what you expect. So I'm just saying, in case that happens, just keep that in mind. Air is not a good conductor of the heat. Let me go back to chat. Okay. Yes, that's true. Air is not a good conductor of the heat, or the electricity. Yes. Okay, if you have any questions, you let me know at this point. If you don't have questions, I'm going to call for attendance, and you watch the video, submit the I'm glad that all of you had followed the instructions with downloading the Word document. You type in your answers, save it, and then upload, please. Don't use the PDF. Do not use piece of paper for answering the questions. Is a Word document, is editable, so you write your answers just like the ones that you did. I think there were like just one or two cases, so I hope that for the next set of paper I'm grading, I see all in Word document, because Word document you can edit. Make sure that it looks nice before you submit it. If there is calculation, pay attention to significant figures, pay attention to units. A number without the units, it could mean many things, many different scales, units. So you don't want to express a number without a unit. And the significant figures, please pay attention to that. Okay, January 26th, Hannah, this is for attendance. Thank you.
Yeah.
Sahar, Sonia, Ashley, Leah, Caitlin, Jennifer, Garrett, Carmen, Danielle, Davis, Caden, Soroti, Katie, Bianca, Manisha, Jada,
Here.
Jose, thank you, Jose, Sierra, Javier, Lillian, Aisha, Matthew, and Ria. Very good. Okay. Any questions for me? Turn it in. Okay, good point about the turn it in. It will be your submissions will be tested against the turn it in, and when there is like a high similarity, I actually open the document. When I open the document, it highlights what are the similarities coming from. The actual question also is going to be similar because it's the same Word document that everyone is using and is the same order of the word, symbols, everything, spacing in between. Turnitin is very strong, a very strong tool. So the only way that would make it 100% or very high percent similarity is if you copy and paste or if you share document. If you don't share document, it will distinguish that it was your own work. And if you do share documents, I guarantee it's going to pick up the similarity. You don't want to share document and start making changes in spacing and everything else, or changing word or two. But if you don't share a document, if you type your answers yourself, is going to show me that they are different. So I don't just look at the percentage. And if you see like high percent similarity, don't be afraid and don't worry about it. I have to open the document and see the highlight if it's coming from the answers or it's coming from the questions. So if it's coming from the answers, it's not, you're not going to lose points for it. Experiment 2 pre-lab. Pre-lab is always due before the lab, right? It's a pre-lab. A pre-lab assignment prior to the lab assignment. Prior to the lab. So 8 a.m. is supposed to be turned in on Tuesdays, pre-lab. If it's talking about the data sheet, then data sheet is due next Tuesday before 8 a.m. Perfect. If you have any questions, please ask at this point. If you don't have any questions, go